Hello friends, welcome back. Today we are going to see 4-point DFT, discrete Fourier transform, by using DITFFT, decimation in time fast Fourier transform. The full form of this, decimation in time. Always mark something over here so you will understand you have to divide the time component. After so this is how to construct 4-point DFT using this particular DITFFT. So 4-point DFT, that means you have to draw two you have the formula n is equal to 2 raised to x. Here x represents number of stages. So your n is 4-point DFT, right? So 2 raised to how much? 2 raised to x. So my x value is 2. 2 raised to 2 will give me 4. So x is equal to 2 represent number of stages. So this is quite basic. So I will draw 4 lines. You need to draw 4 lines. One, keep a gap of 2, leave 2 space, and then draw 4. Like this you need to construct your 4 lines. Number of stages 2. So this is my stage 1 and stage 2. Again I have to draw 4 lines. How I am drawing exactly, you need to draw the same. Leave space in between. Now this is you have to find DFT. What is the meaning of DFT? DFT, this is the very basic. DFT means discrete Fourier transform. What happens in DFT is you have x of n with you and you need to get x of k. Okay, so this is DFT, discrete Fourier transform. In this you have given x of n, that means time domain, and this is frequency domain. So x of n is time domain, x of k is frequency domain. So DFT is this particular term. So this is very basic. And so I have given x of n. So my x of n is the input and my x of k is the output. Capital X of k is my output. So this is input, write your input x of n. This is your output x of k. After knowing this particular thing, you need to understand one basic and simple table that you need to remember. Draw this table and you will get all the butterfly diagram. Draw this table. Small butterfly, big butterfly, and here big butterfly, small butterfly. B stands for butterfly. Okay, so remember this particular table, DFT, and now read this 4-point DFT using DITFFT, decimation in time. Decimation in time using DFT, right? Check this table and this. So my butterfly diagram will start from here, small butterfly. That means I have to draw small butterfly. How to draw butterfly? Simple rule, connect this to this for small butterfly. In this point with this, remember the end point will give -1. -1, and this completes your stage 1. That means small butterfly. From how will you understand? We have to draw small butterfly from this table. Draw this table, DFT and DITFFT, small butterfly. So I have drawn small butterfly. Then immediately next draw big butterfly. To draw big butterfly, take first point and mark it to the third point. First connect first with third line, connect second line with fourth line, and complete this. First with third, second with fourth. Okay, and where this line is connecting, write -1 -1 at the end. You have to remember two things for big butterfly. For big butterfly, you have two components, W4 is to 0 and W4 is to 1. Why W4 is to 0? Because we are doing 4 point. That's why W4 is to 0. And W4 is to 1 because we are doing 4 point DFT. So W4 is to 0. Multiply over only to the big butterfly diagram. Remember these two components. And the basic thing, this is my output. So I have to divide the time domain. This is my time domain. I will divide it. So this is x of 0, x of 2, x of 1 and x of 3. How to divide this? Simple thing. Even component first, 0 and 2 is even, then write odd component. Decimation in time, that's why I have divided x of n component, because it is time domain component. While as frequency domain component, I will not divide. So I will just write x of 0, x of 1, x of 2 and x of 3. There is no need to divide the frequency components, only time domain component division. So this whole thing, and here you can write A, B, C, D as the output of this small butterfly. This completes the full diagram, butterfly diagram for 4 point DFT using DITFFT. So this is the simplest and the simple thing you need to understand in order to proceed with the numericals.